A bus travels 280 kilometers south along a straight path with an average velocity of 88 kilometers per hour to the south. The bus stops in 24 minutes and it travels 210 kilometers south with an average velocity of 75 kilometers per hour to the south. How long did the total trip last? Was the average velocity of the total trip?
Check my numbers real quick, make sure those are right. I just jotted them down real quick. How long did they stop for?
24 minutes.
24 minutes. All right. 280, thank you. Okay. So we've got three parts to this problem, right? All of which we're going to then sum together. We know how long it took for this duration for the break. Leave it in minutes for now. We can either convert that to hours later or get answers for these in hours and convert those to minutes. Leave it for now then. If you travel 280 kilometers at 88 kilometers per hour, you could figure out how much time it takes to travel that distance. You could then also figure out how much time it takes to travel this bottom distance. Add those three times together to get the total time. What did people get for the first part? How much time, man?
280 by 3.2 hours or 192 minutes.
For this part right here?
Yes.
3.2 hours?
Yeah.
And what was that in minutes you said?
192 minutes.
And how about the second one? I'll put the third one, really. I'll put T3. Sierra?
I got 210 over 75, and I got 2.8 hours.
Good. And in minutes, did you happen to convert that?
Yeah, I can convert it.
Somebody times 60, please. What do you got?
168 hours. I mean minutes.
Minutes? Gotcha.
Wait, is it bad that I didn't convert it into minutes?
No. As long as you converted the middle into hours,
Yeah.
then. That's fine. So this is T2. And T2 is given as 24 minutes. But if you think about that in hours, that's really how many hours? 0.4, 4/10, right? Think about 6. 6, 6, 6, 6 gives you 4, but 6 10 times gives you 60. So this is yours 4/10. So you could also say, or 0.4 hours. So we do one of two things. We add up these three. Okay, that works by adding those three numbers. In hours, you get an answer. Or you go ahead and add up the other three. 1, 2, 3. That are circled in this like lighter color yellow. These are kind of weird colors. This lighter color, and you get the answer in minutes. It doesn't matter either way. It really doesn't matter. Part 2, though, says find the average speed or average velocity. Ellie?
Yeah.
What did it say? Exact words?
The average velocity.
Average velocity. So we want the average velocity. We know that velocity is displacement over time. That's all you have to do. What's the overall displacement? How many kilometers?
490.
There's 400. This is part B now. There are 490 kilometers of displacement. And if you want the answer in kilometers per hour, just divide it by the total time it took by summing those three numbers together. Whatever answer you got for part A, pretty much divide it into 490. And you get your answer in kilometers per hour or kilometers per minute. Either one. That make sense, Ellie? All right, 3.2 and 2.8 gives us 6, so I'll do it over 6.4 hours. And that'll give us some average velocity. What do we get for that?
78.
Now, do me a quick favor and take a look. What do you think the common mistake is? What do you think the common mistake? It's 78 kilometers per hour is the answer. What do you think people might do, just instinctively? That's good that nobody thinks that, because then it's the wrong thing, so it means we're not thinking the wrong thing. Yeah? You might just use...
Just multiply
Well, let me just explain what I was thinking, because maybe I'm just thinking it differently. I heard what was the average velocity, right? So I thought some people might just average these two numbers together. Okay, you can't just average these two numbers together, right? This portion of the trip was for a longer displacement than this portion of the trip. And there was this break in the middle. So clearly we can't just average these two. But if this were like a multiple choice kind of question for a part B, which probably wouldn't be a multiple choice actually at all, but the common mistake would be to average those two together. Do you understand why we can't just average the two together? Because there's a time lapse in the middle and you're taking each segment for a different length. Okay, they're not equally weighted.
When you have 490, did you subtract the two numbers?
I added the two distances, 280.
Aren't you supposed
Plus
to
210.
subtract them? Like, because it would be...
Weren't they both going south? What did it say in the problem?
So does that mean you add...
Think about the path traveled, right? Okay. You go south for 280 kilometers. If you went north for 210, then yes, it would be 70 kilometers.
Okay.
And you'd subtract the two.
Okay, so you have,
But because you're pausing and continuing south,
Okay.
that's why.
Okay, so it's not...
There was no change in direction, exactly. Okay, if there were a change in direction, definitely subtract the two. Good? Okay? All right. A problem like this is very similar. You could expect something like this simple on the test, but maybe instead of going down and then down further, it says this. It then goes west. Say instead of 280, 130 kilometers at a rate of 70 kilometers per hour. Okay, so imagine that this was not here, and that was the new problem. Okay, if you want to practice something tonight, practice that. Think about how your displacement will work from start to finish. What would you have to solve for here? What's it called? Yeah, using Pythagorean theorem. You find the hypotenuse length. So the displacement from start to finish for something that goes south and then west, or north and then east, or north and then west, or whatever. If it changes directions at 90 degrees, use Pythagorean theorem, get the hypotenuse. That'll give you your overall displacement. Instead of 490 now, you'll have 280 squared plus 130 squared equals h squared, or x squared, or c squared, whatever the heck you want to call it. Okay? But get the idea in your mind for that. Other questions on the problem set? Page 64, number 3. Yeah, sure.
A tennis ball is thrown up vertically upward with an initial velocity of positive 8.0 miles per second.
Meters?
Meters.
That's all right.
What will the ball's speed be when it returns to its starting point? How long will the ball take to reach its starting point?
So here's what we have. The ball is tossed straight upward. It reaches some height. We want to figure out what the final velocity will be when it lands and how long it takes. Is that right? And how long it takes, the second part? What's the final velocity when it lands? Just by inspection. It's -8. If the problem has symmetry, you can start with that. That's the first part. Now, if you forgot that for some reason, and you wanted to figure out how long it was in the air for, right? You'd have to go about figuring out your time. So we have to consider the fact that we have to look at time now. Now, when this lands back here, this is our question mark, but we could put -8 meters per second simply due to symmetry. We could also have done this. We could have said, well, y is equal to 0 meters if it starts and ends at the same spot. And from that information, we could have used this. And what you recognize, Katie, is that if y is 0, what happens to this whole term? Yeah. So you'll see that VF and VI are really the same thing, but you have to consider the direction they're moving. So VF is just 8, but it's -8. Now to find the time, you could use VF equals VI plus AT. If you want the whole time, instead of finding the time to the top and then doubling it, you could find the whole time by using this. Now, if you call VF 0 and find the time it takes to get to the top, just double it, and you get the overall time. But if you call VF -8, inherently you're going to double it, because watch what happens. Let me show you mathematically. If VF is considered to be -8 and VI is considered 8, I'm not solving generically because I'm going to show you the math here. Take a look at what happens. When I move this 8 over, what does this become? What's negative 8 minus another 8? Negative 16. And then you would divide negative 16 by negative 9.81. Okay, so keep that in mind, all right? Negative 16 over negative 9.81. Now, if I did it the other way, where I found the time to get to the top and then doubled it, I would have to make my VF 0 if I did that. This would become a 0, which would make this a 0, which would make this now negative 8 when you subtract it over this. So instead of a negative 16, you would get negative 8 over negative 9.81. Well, the time at the bottom here is double the time at the top. Well, the time at the top is literally this in white here, this one I'm circling. This is the time it takes the ball to reach max height. So you would literally double that answer. Inherently, though, you are doubling it by solving this way. By plugging in the negative 8 as your final velocity instead of 0, you're getting double the answer because this expression is double this expression anyway. So you could solve this by one of two ways. Find the time it takes to get to the top, here, and then double it. Or set y equal to 0 this way, get your final velocity when it hits the ground, and consider the ground as your ending, and go all the way up and come all the way back down. Either way works. Where are you at?
Like,
Right here?
Yeah, just like the
Yeah, so what you need to do is kind of, you're trying to find what your VF is. So VF is going to be the square root of VI squared with a plus or minus, which really means just that VF is plus or minus VI. It's the same as VI, but it's positive or negative depending on the direction.
I always get whenever I saw it was a square.
Well, when you have a square doesn't get rid of the square, it just magnifies the square, right? It'd be like saying, I'm multiplying, so let me multiply again. To get rid of multiply, what would you do? So the same thing here. If you square something that's already squared, it does the same operation. You want the inverse operation. And the inverse operation of a square is always a square root. You just have to memorize that one. If you have something that's under a square root and you want to get rid of it, then you square both sides.
So technically, it's like I would go with it, plug in 8.
Oh, yeah, you could do that. But then you take the square root, what do you get back to? You get 64, but then you have to take the square root, which brings you back to 8 anyway.
Oh, okay. So
You know what I'm saying? So like if you square, that's what you meant by squared. Okay, I see what you mean. So if you put the 8 in here, you get VF squared equals 64. But then you got to square root it anyway. Square root of 64 is back to 8.
okay.
So I'm just canceling out the square root and the square and going right to this right here.
It was solved at a weird angle.
Well, you should get the same answer you started with. So if you got a different answer,
I know because I
then-
didn't find the square root of it.
yeah. Other questions on the problem set? Yeah.
For number 1 of the same page, like 64, aren't you supposed to use negative 9.81 for acceleration?
What does it say? Does it say on
'cause
Mars?
It said equating the acceleration.
I think that was the one on Mars. Because remember, negative 9.81 is the acceleration due to gravity
Oh,
on Earth. If it said on Mars, was it like 3.7
yeah,
or
it was
something?
3.7, and I put that in there.
Yes. So for that problem, when it gives you the acceleration due to gravity, you would do that. Now, what about a problem like this? What if I tell you that it takes, it takes 10 seconds for an object on Jupiter, well, let's say, I don't know, because Jupiter's gravity is 22.9, and I don't know what it's going to work out to be. So let's say it takes an object 10 seconds on planet X, doesn't matter what planet, to fall a distance, right, jot this down. It takes 10 seconds for an object to fall a distance of 25 meters. So it takes 10 seconds for an object to fall a distance of 25 meters. Determine the acceleration due to gravity on that planet. Determine the acceleration due to gravity on that planet. Can somebody else tell me these other variable values I can plug in? What's VI and what's Y? Give me one of those, Theo.
The initial velocity is 0.
How come?
Because you're
Good. Not thrown down. Takes an object 10 seconds to fall, like a free fall, to fall. Katie? Yeah, good. And that's the other key point. Y's got to be negative. If you made Y positive, what would happen? You'd end up getting a positive acceleration, and the acceleration is going to be down, so the acceleration's got to be negative, right? So how would I solve this? How would I go about solving? This might seem a little confusing at first, because we haven't done a problem where we solve for acceleration yet. What formula would you use? But you don't know VF. You don't know A. Right? You don't know VF, so you can't use VF formula. There's only one that doesn't involve VF.
Y equals VIT plus 1/2 AT squared.
Okay, this is the only one that doesn't involve VF. And we don't know VF and we don't know acceleration. What's the key here? What's the interesting part that helps us a little bit? Actually, it doesn't matter. It could be thrown with some velocity. Let's say that it was, well, whatever. It doesn't matter. But do you see what I'm saying here? See where VI is? We're going to drop VI off. This drops off because it's 0. But I could have thrown this object down with the velocity of 5 meters per second, and then you just have to plug in a 5 here and plug in the time of 10 here, and you can still solve for A. So this does not have to be an object that's dropped from rest. I could have told you it was thrown downward with some initial velocity. Okay? Anyhow, let's get back to the problem. How do we figure out the acceleration due to gravity on this planet? Once that's 0, we get this, right? Some of you had trouble with this, either on homework or on problem set when you were asking questions. How do I get rid of a 1/2? How do I get rid of a 1/2, Katie? Yeah, please multiply by 2. Please don't divide by 1/2. It's the same thing, really, right? But when you divide by 1/2, it looks funky. So cross these off here. I get 2y equals AT squared. Bless you. Divide by? Divide by? Ellie? We're trying to find A. T. I couldn't hear that last part. To the second, squared, right? Divide by T squared on both sides. That's what A is. Okay? 2y over T squared. That make sense? Any free fall, literally any free fall on any planet, you could use this exact formula. If you drop something, if you walk on a planet's surface, give me 1 second. If you walk on a planet's surface, right, and all you have is a tape measure and a stopwatch, you can calculate the acceleration due to gravity. All you got to do is calculate how long it takes to fall a certain displacement over a certain time period, and you have acceleration. It's pretty amazing to think about it. It's all you need. There's many ways to find acceleration due to gravity on different planets. This is one of the many ways.
Could you say A equals the square root of 2y over t, or do you actually keep t squared?
Oh, how would you do that?
No?
A is not squared, is it?
Oh, right.
Unless, remember, only if the variable of interest is squared can you take the square root. You are not looking for t in this problem. If you were looking for t, then yes, you would square root both sides. Okay? After you've isolated t squared, then you would square root it. But here we're looking for a, which is not squared. Okay, so these kinds of problems are the ones you can definitely expect, where you might not have seen something like this before, but all the problems you've done in your problem set and your homework have prepared you to say, all right, I need to attack this problem and say, what's going on here physically? What do I know? What are my options for formulas? Which of the formulas actually works? And hint, if I give you something with parts A and B, do it in the order I gave it to you. I'm most likely, I'm not going to probably I would never just put it in reverse order, where you can't get part A before getting B, right? So if I give you parts A, B, C, do part A first and isolate, or whatever, figure out the answer for part A, because you might have to use it in part B. And what if you can't find part A again? Anybody remember what I told you? Can't figure out? What is it? Yeah, pick a number that's somewhat logical, right? So if part A says find the final velocity, and you tell me that when it's falling down, the final velocity is 4 meters per second, that's not logical. it's got to be negative if it's going down, right? So if your part A says find the acceleration due to gravity, and you give a positive answer, not very reasonable, right? Okay? Again, here, it's clearly going to be negative because y is negative. We get negative 50 over 10 squared. Well, it's going to be negative 50 over 100, so negative 0.5, actually. This is easy. Okay, a very, very, very small acceleration due to gravity. This would be a very, very small planet. The more massive a planet is, the more its gravitational pull is. That comes from Newton's law of gravity. It's G, capital G, not little g. M1, M2 over R squared. M and M are the mass of the object and the mass of the planet, or the central object. So bigger planets like Jupiter, even though Jupiter is made of mainly a lot of gas, it has a lot more mass than the Earth still. And its gravitational pull is almost triple that of the Earth. Whereas the Moon, much smaller, is 1/6. So when you're doing a test, use logic, right? If you get an answer that's not reasonable, stop and ask yourself why. All right. I'm going to pause at that point, okay? And we're going to take a look at the lab. If we have more time at the end, I'll add on to the rest of this recording.